In this video, I'm going to look at some non-calculator exam style questions on percentages. I will be looking at 5 types of questions, and for each type of question, I will be looking at 2 examples. Before looking at the questions, here is some thinking you might wish to consider. Remember, percent means out of 100, so 35% can be written as 35 over 100, or 17 over 100 can be written as 17%. So 100 is the magic number here, and therefore you also might wish to consider some numbers that go exactly into 100, as you might be tested on this. So we have 2 and 50, because 2 multiplied by 50 is equal to 100. Then there's 25 and 4, because 25 multiplied by 4 is equal to 100. And finally, there is 20 and 5, because 20 multiplied by 5 is also equal to 100. Also be aware of multiples of these numbers, especially 20 and 25. I will be referring to this throughout the video. You also need to be comfortable with equivalent fractions and multiplication, but hopefully this information will become clearer as we look through the following examples. I do recommend for each question to pause the video and have a go yourself, just to see what you can do. You never know, you might get the right answer. So here's the first type of question. A student throws a dice 5 times and scores a 6 on 2 of the throws. What percentage of the throws does the student score a 6? There is only 1 mark for this question, so the expectation is that you should be comfortable in turning this into a percentage. So what the question is saying is that 2 of the 5 times that the dice was thrown, it produced a 6. Well, let's write this as a fraction, 2 over 5. What is 2 over 5 as a percentage? We want to write this fraction as an equivalent fraction of something over 100, because we want to find the percentage. Using this information here, if I multiply this 5 by 20, I get 100. I therefore need to multiply the numerator, that's the 2, by 20. Well, 2 multiplied by 20 is equal to 40. So we have the equivalent fraction of 40 over 100, which is 40%. And there's your answer. Here's a similar type of question. In a mathematics exam, 15 out of the 25 students achieved an A grade. What percentage of students achieved an A grade? So what the question is saying is that 15 out of 25 students achieved an A grade. So let's write this as a fraction, 15 over 25. What is 15 over 25 as a percentage? We want to write this fraction as an equivalent fraction of something over 100. Looking at the information again, if I multiply this 25 by 4, I get 100. I therefore need to multiply the numerator, that's the 15, by 4 as well. 15 multiplied by 4 is equal to 60. So we have 60 over 100, which is 60%. So there is only 1 mark here, and this means that you need to be comfortable in writing down the fraction, then writing it as an equivalent fraction out of 100, before writing it as a percentage. I would like to think that in a non-calculator paper, they will try and keep the numbers relatively simple. Another type of question you might come across is like this, where you have to increase an amount by a specific percentage. Increase 60 by 32%. There are different ways of doing this, but this is how I approach the question. I'm thinking of 32% as 30%, which is 3 lots of 10%, add 2%, which is 2 lots of 1%. The reason for this is that finding 10% and 1% of something is relatively straightforward. For 10%, you divide by 10, and for 1%, you divide by 100. So 10% of 60 is 60 divided by 10, which is 6. So 30% of 60 is 3 lots of 6, which is 18. 1% of 60 is 60 divided by 100, which is equal to 0.6. So 2% of 60 is 2 lots of 0.6, which is 1.2. So to increase 60 by 32%, we have 60, add 18, add 1.2, which is equal to 79.2. There are 2 marks for this question. You would get a mark for the working out of 32% of 60, and then another mark for the answer, which you get by adding 32% to the original amount of 60. There are other ways in which you can work this out, but I think this is one of the easy approaches, as you are not dealing with any difficult calculations. Here's another similar type question. Increase 70 by 45%. I recommend that you pause the video and have a go. I will be applying the same approach to this question as I did with the previous question. Again, we can break the 45% down. So think of 45% as 40% and 5%. So 40% is 4 lots of 10%. 10% of 70 is 7. So 40% of 70 is 7 multiplied by 4, which is equal to 28. Now for the 5%. We could find 1% of 70, which is equal to 0.7, and then multiply that answer by 5. So that's 0.7 multiplied by 5, which is equal to 3.5. But in this particular example, we could do this slightly differently. 5% is half of 10%. We know that 10% of 70 is 7. So 5% of 70 is half of 7, which is equal to 3.5. But it doesn't matter which way round you do it, as long as you get 3.5 for 5% of 70. Now to get the answer. That's 70, the original amount, add 28, add 3.5, which is equal to 101.5. So again, there are 2 marks here, 1 mark for calculating the 45%, and 1 mark for adding the 45% to the 70 to get the answer. Now for the third type of question. Write 26 as a percentage of 40. This type of question is very similar to the first question. We need to write the question as a fraction, then convert it to a fraction out of 100, and then that will give us the percentage. It's just that the numbers are slightly more challenging. So for starters, let's write this as a fraction. That's 26 over 40. In order to find the percentage, we need to write the fraction 26 over 40 as an equivalent fraction over 100. So we need to get from here to here. Now the challenge with this question is that 40 doesn't go exactly into 100. So it's not a straightforward multiplying the top and bottom by the same number. Let's look at this information again. We know that 40 is a multiple of 20, and that 20 goes exactly into 100. So look at what I'm going to do. If I divide the denominator, which is 40, by 2, I get 20. If I multiply the 20 by 5, I get 100. So for the denominator, I have divided by 2 and then multiplied by 5. I therefore need to replicate this for the numerator. So 26 divided by 2 is equal to 13. I now need to multiply this by 5. 13 multiplied by 5 is equal to 65. So we have 65 over 100, and this of course is 65%. So in order to get our 65 over 100, we actually wrote an equivalent fraction of 13 over 20 before converting that fraction as 65 over 100. There are 2 marks for this question. That's 1 mark for writing the equivalent fraction of 26 over 40 as 65 over 100, and 1 mark for writing 65 over 100 as a percentage. Let's look at a similar example. Write 27 as a percentage of 75. Have a go at the question yourself before I go through the answer. So again, let's write this as a fraction. That's 27 over 75. We need to end up with something over 100. Let's look at the information again. 75 is a multiple of 25. That is, 3 multiplied by 25 is equal to 75. 25 goes into 100 exactly 4 times. So let's use this information. The denominator is 75. If we divide 75 by 3, we get 25. If we now multiply the 25 by 4, we get 100. I need to replicate this for the numerator. We have 27 divided by 3, which is equal to 9. So we have now written an equivalent fraction of 9 over 25. We then do 9 multiplied by 4 is equal to 36. So we have 36 over 100. And this, of course, is 36%. Again, that's 1 mark for writing 27 over 75 as 36 over 100, and 1 mark for writing 36 over 100 as 36%. The next type of question I'm going to cover involves amounts that have been decreased by certain percentages, but we don't know what that amount was to start with. Have a look at the following question. A jumper is sold for £24. This price includes a 20% discount. What was the original price of the jumper before the discount? So we need to find the original price of the jumper. This requires a bit of thinking. But here's what's going on in my head. So we have the original price of the jumper, which we don't know. Let's call it OP for original price. But we don't know what this price is. If I subtract 20% of the original price from the original price, we have the answer £24. Well, this would mean that the £24 is 80% of the original price of the jumper, because we took 20% away from the original price. So think of the original price of the jumper as being the 100%. We subtract 20% from it, and we are left with 80%. So we need to find this 100%, as this is the original price. Again, we need to think about numbers that go exactly into 100. 80 is a multiple of 20, and 20 goes exactly into 100 5 times. So if 80% of the original price is £24, if I divide that 80 by 4, I get 20. So this means that 20% of the original price is 24 divided by 4. So 20% is equal to £6. Remember, 100% of the original price is the original price. If I multiply the 20, that's the 20%, by 5, I get 100%. I therefore need to multiply the £6 by 5, and this gives me the answer £30. So £30 is the original price of the jumper. Now there are different ways of working this out, but however you work out the answer, 1 mark will be given for the working out and 1 mark would be given for the correct answer. Have a look at this question. A second-hand watch is sold for £36. This is 25% less than the price it was originally sold for. What was the original price of the watch? Again, here's what I'm thinking. The original price, subtract 25% of the original price, is equal to £36. This means that the £36 is 75% of the original price, because we have subtracted 25% away from the original price. So think of the original price as being the 100%. We've subtracted 25% from it, and we're left with 75%. Again, we need to think about the numbers that go into 100. We know that 75% is a multiple of 25, because 25 multiplied by 3 is equal to 75. And 25 goes exactly into 100 4 times. Well, let's use this information. If 75% of the original price is £36, and I want to find 25%, then I need to divide the 75 by 3. This means that 25% of the original price will be £36 divided by 3, which is equal to £12. 100% of the original price is the original price. We know that 25 multiplied by 4 is 100. So to get from 25% to 100%, we multiply by 4. We therefore need to multiply the 12 by 4 to get 100%, which is equal to 48. So the original price is £48. Again, 1 mark will be given for the working out and 1 mark for the correct answer. The final type of question I'm going to look at involves simple interest. Simple interest is the amount of interest added each year and is calculated from the original amount invested. Have a look at the question. Samantha invests £500 in a bank account. The account pays 2% simple interest each year. How much money will she have in her account after 4 years? So the original amount being invested is £500. The interest is 2%. So after each year, 2% of £500 will be added to the account. Well, 1% is equal to £5. That's 5 divided by 100. So 2% is equal to £10. The question is asking, what will be in the account after 4 years? Well, the amount of interest after 4 years will be 4 lots of £10, which is equal to £40. So the amount of money in Samantha's account after 4 years will be £500 at £40, which is equal to £540. For this particular question, there are 3 marks. 1 mark for correctly working out 2% of £500, another mark for working out the total interest over 4 years, that's 4 multiplied by £10, and finally 1 mark will be given for the correct answer by adding the £40 to the original investment of £500. And one final question. A bank is offering 3% simple interest on a saver account. If Peter invests £200 in this saver account, how much money will he have after 3 years? Do pause the video and have a go at the question yourself before I go through the answer. So this time the interest is 3%, and the original investment is £200. So at the end of each year, 3% of £200 will be added, and the time period is 3 years. We'll begin by working out the interest that will be added each year. 1% of £200 is £2, because that's 200 divided by 100. So 3% is 3 lots of £2, which is £6. So after 3 years, 3 lots of £6 will be added. So that's £6 multiplied by 3, which is equal to £18. Therefore, the amount Peter has in his account after 3 years is £200 add £18, which is equal to £218. Again, there are 3 marks. 1 mark for working out 3% of £200, another mark for working out the interest after 3 years, and 1 mark for the final answer. I should point out that the marks being awarded in each of the questions above are a guide. I guess the point is to make sure that you show you're working out in the space provided as marks are awarded. If you make a mistake in your final calculation, but the method is correct, there are marks up for grabs. Anyway, there are some examples of non-calculator questions on percentages. I haven't covered all the possibilities, but hopefully there is enough here to help you with your revision. I appreciate that the approaches I have used might be different to the way that you would calculate it. If this is the case, I hope that this has given you an alternative strategy for tackling questions like this. Again, regardless of the approach you use, show you're working out. But I hope you found the video useful, and thank you for watching.